Wyoming's Yellowstone National Park is one of the unique places on Earth. Not only is it the site of a massive volcano, but it's also home to an active geyser field and a variety of other hot springs and geothermal features. Visitors can see steam rising from the ground, bubbling mud pots, and even geysers erupting. It's also a marvelous place to see wildlife, which includes bison, elk, antelopes, wolves, and bears. The location of Yellowstone makes it a bit remote, and the geothermal features can be dangerous. The Yellowstone National Park extends over 3,500 square miles, sitting atop a volcanic hotspot, and most of the park lies in Wyoming, while some parts do spread to Montana and Idaho. Canyons, alpine rivers, and lush forests are features that are typical of the Yellowstone National Park. Yellowstone National Park would be built on top of a supervolcano. Supervolcanoes can be described as volcanoes that produce more than 1,000 cubic kilometers of gas, ash, magma, and rock. Lake Toba in Indonesia, Lake Taupo in New Zealand, and Yellowstone in the United States are all supervolcanoes that erupted less than 100,000 years ago. In the past few months, there have been a huge sudden uplift inside the volcano system. This uplift is likely due to increased magma below the surface. While there's no immediate danger of an eruption, geologists are closely monitoring the situation. Join us as we embark to Wyoming to explore the ravishing beauty of the Yellowstone National Park and learn more about the huge sudden uplift in the volcano system that Yellowstone National Park officials detected and the threat that it poses. The Yellowstone hotspot has been stable for a long time now. As the North American continent has drifted southwest, the old eruptions that occurred in the Yellowstone region can be associated with the region that we now call the southeastern part of Oregon. The most recent outbreaks occurred in the northeast corner of Wyoming. The Yellowstone supervolcano has had 3 significant eruptions, the last one happening 640,000 years ago. The supervolcano is responsible for the park's hot springs, geysers, and other hydrothermal features. The supervolcano also created the caldera, where the park is located. The caldera is a bowl-shaped depression that forms when a volcano's magma or lava is ejected. The caldera at Yellowstone is about 34 miles wide, and after the last eruption, the supervolcano entered a period of dormancy. Over time, the caldera filled up with water, and deforestation began. This created an ecosystem that is home to many different animal species, and Yellowstone National Park is a sanctuary to one of the world's largest supervolcanoes. According to park officials, the supervolcano is showing signs of life. The Yellowstone National Park would be built in 1872 and is named after the yellow sandstone found in the area. The volcano lies in northwestern Wyoming, where the major Yellowstone is contained, and one must wonder how the ground lifts and sinks back down. We know that the supervolcano rests on a hotspot that's made of a molten and semi-molten rock known as magma. The ground swells up when the magma feeds into a magma chamber or reservoir 4 to 6 miles underneath the Yellowstone National Park. When the magma cools off and solidifies, the ground then sinks in. Volcanologists have been measuring this volcanic activity since 1923, and according to them, the ground rose some 9.8 inches between 2004 and 2009. In 2010, however, the land then began to subside. The slow, steady rise had many scientists wondering if the Yellowstone would erupt soon and how violent the eruption would be. Earth Sciences professor of the University of Northern Colorado and renowned volcanologist Dr. Steve Anderson said, "The big question is, if Yellowstone started shaking tomorrow, what is there to expect?" He also went on to add, "I don't think we know exactly what to expect. However, scientists think it wouldn't be any less than a doomsday." The Yellowstone Plateau volcanic field forges the high continental partition between the northern and central Rocky Mountains. The plateau reaches an average elevation of 7,900 feet and is encompassed on all sides by mountainous terrain, with peaks as high as 13,000 feet, except in the southwest. The eastern Snake River Plain stretches to the southeast as a structural depression about 350 kilometers long. For 2.2 million years, the 17,000 square kilometer Yellowstone Plateau has been carved by explosive eruptions, deep ground collapse, intensely thick lava flows, ground uplifting, extended faulting, and the erosive power of running water and ice. Dr. Jacob Lowenstern, scientist in charge at the Yellowstone Volcano Observatory and research geologist, explains that Yellowstone is currently an inactive volcano with low levels of restlessness. He further says that there's no current activity going on that would indicate anything happening, and if something was coming, there is nothing to show at this point in time. The Yellowstone Plateau volcanic field has undergone 3 volcanic cycles spanning 2 million years. 2 of these supervolcanic eruptions are deemed some of the world's most extreme volcanic events. Lava flows resulting in the last 77,000-year-old eruption of Pitchstone Plateau were limited to the caldera of what we now call Yellowstone National Park. The first eruption occurred 2.1 million years ago at the Huckleberry Ridge Tuff, creating a 75-kilometer wide caldera and vicious volcanic deposits. The second cycle was when the Mesa Falls Tuff erupted 1.3 million years ago, and the last activity would be recorded 640,000 years ago at the Yellowstone Plateau when the Lava Creek erupted, forming a caldera of dimensions of 45 by 85 kilometers. Rhyolitic lava flows of 600 cubic kilometers were gushed into the caldera between 180,000 and 70,000 years ago, and since then there have been no magmatic eruptions. Nevertheless, hydrothermal explosions occurred during the Holocene, the period of the last 11,700 years of the Earth's history. 2 uplifted regions, Mallard Lake and Sour Creek, are the centers of uplift and subsidence of the ground surface. These spots are called resurgent domes. In geology, a resurgent dome is a dome-shaped feature developed by the dilation or rising of a caldera floor due to a change in motion in the magma chamber under it. Currently, the geologic activity of the Yellowstone National Park is limited to hot springs and geysers. Enormous earthquakes occur near the plateau, close to the Teton and Hebgen Lake faults. The Hebgen Lake fault ruptured in 1959, damaging the region considerably, and Yellowstone is presently one of the Earth's largest sites, consisting of hydrothermal systems and the highest concentration of geysers. Earthquakes occur routinely in the Yellowstone region. Yellowstone is one of the world's most seismically active regions. The vast network of faults linked to the supervolcano and the surrounding tectonic features result in about 700 to 3,000 earthquakes occurring yearly in the area, most of them being small in magnitude. Tectonic plates beneath the Earth's surface are constantly slowly moving. Earthquakes happen when these tectonic plates get stuck at their edge because of friction. When the tension on the edge overcomes the friction, energy is then released in waves that travel through the Earth's crust, causing the ground beneath us to shake. Tectonic plates are massively irregular solid rocks comprising continental and oceanic lithosphere. In July of 2022, the University of Utah seismograph stations that overlook the operations and analysis of Yellowstone's seismic network would locate 59 earthquakes in the region. The month's main event was a minor earthquake of a magnitude featuring 3.1, located 14 miles southwest of the Mammoth Hot Springs section of Yellowstone National Park on July 30th. The event was part of a small series of 13 earthquakes between the 29th and 30th of July, and such earthquake sequences make up about 50% of the entire seismicity in Yellowstone, a region that was a shallow inland sea for millions of years. The topography of this zone is characterized by sandstone, slates, and limestones made of shells of tiny aquatic organisms that are amassed over time. It's also a zone of consistent hydrothermal activity and faulting. Hot fluids from the Yellowstone caldera move upward and mix with marine sediments, picking up calcium carbonate. When these fluids reach the surface, calcium carbonate is deposited, which creates gorgeous terraces. Mammoth Hot Springs is a travertine hot spring that's different from the Old Faithful. Old Faithful is typified by neutral chloride hot springs, and the acid sulfate hot springs dominate the mud volcano. Old Faithful is situated in Yellowstone's upper geyser basin in the southwestern area of the park. and it sprouts more than 14,000 liters, or 3,700 gallons of boiling water, more than 30 meters up in the air about every 90 minutes. Discovered in 1870 by the Washburn Expedition, Old Faithful was named after its recurring and predictable eruptions, which account for more than 1 million eruptions since Yellowstone was turned into a park in 1872. Old Faithful is the world's most famous geyser, erupting up to 20 times per day. These eruptions range in heights from 100 to 180 feet, averaging nearly 130 to 140 feet, lasting anywhere between 1.5 to 5 minutes. Due to groundwater accumulation, seasonal uplift detected by a GPS network continued in July. Yellowstone remained at background levels of activity the whole month. June was somewhat more eventful. Heavy rainfall and snow melting would lead to record flooding in the Yellowstone region from the 10th of June through the 13th. Several landslides and rockfalls occurred, especially on the northern side of Yellowstone National Park. Some roads and bridges would be washed away. Floods in the Yellowstone would wreak havoc in the region. Infrastructure and homes were damaged to a great extent, so much so that it isolated entire communities. Floods did not instigate any detrimental seismic activity, though, nor was the hydrothermal activity in any way influenced whatsoever. However, there was a significant impact on the geyser activity. Geysers began erupting more frequently because they tend to emit more often during times of high precipitation compared to the more drier periods in the year. The timing shift is subtle but statistically substantial. Steamboat Geyser erupted twice on June the 10th and June 20th. There have been 8 notable eruptions of a geyser in 2022. The University of Utah seismograph stations located a tremendous number of 149 earthquakes. The most prominent event of the month was a minor earthquake of a magnitude featuring 2.4, detected 13 miles southwest of Mammoth Hot Springs on June the 12th. These earthquakes occurred in 3 swarms. A small series of 11 earthquakes 15 miles south of West Thumb in Yellowstone National Park would be recorded on the 7th of June. The highest magnitude recorded was a 1.5, with another series of 67 earthquakes, the most prominent being a quake with a magnitude of 2.4, occurring on June the 12th in the southwest Mammoth region. The last one was a swarm of 29 earthquakes that continued on in the same area, 13 miles southwest of Mammoth Hot Springs, occurring between June 20th and June 30th, with a trembling magnitude of 1.4 being the largest of the last of the series. GPS stations in Yellowstone caldera near Norris Geyser Basin recorded a few millimeters of uplift since the summer started. This uplift occurs when the snow melts and oozes into the ground, causing it to swell. There's been a trend of caldera subsidence of a few millimeters every year since 2015, and gradual subsidence of 2 to 3 centimeters, or 1 inch, has been recorded annually for the past couple of years. The Yellowstone region experiences an average of 1,500 to 2,500 earthquakes on a yearly basis. Most of these are too little in magnitude to even be felt by humans and are detected only by a refined network of 50 seismometers known as the Yellowstone Seismic Network. According to experts, the Yellowstone supervolcano is highly unlikely to erupt. However, the recent underground activity does fuel speculation about the intensity of an eruption. The past decade has witnessed the fastest rate of the ground surface rising in Yellowstone. While most of these earthquakes are virtually unnoticeable, they do provide scientists with an insight into how quickly the magma chamber under Yellowstone is filling up. Increased shaking and quivering all throughout Yellowstone indicates that fresh puddles of magma recently drained into the reservoir. Experts believe that even with the increased number of tremors, there are no foreseeable perilous circumstances as of yet or anytime soon. Regardless of those facts, it's impossible to monitor and analyze every minute detail of the happenings at Yellowstone National Park, which makes it difficult for geologists to predict the supervolcano's next action. Examinations of past eruptions after some clues, the 3 colossal eruptions within the last 2.1 million years had gaps of about 600,000 to 800,000 years between them. Effects of the last major event that occurred 640,000 years ago sprawl over the whole park and across thousands of miles in the surrounding landscape. Each of the three treacherous eruptions spewed gigantic amounts of volcanic ash, gas, magma, and other volcanic rubble that shrouded most of the continental U.S. Some material has even been discovered as far off as Louisiana. After every eruption, the Yellowstone supervolcano collapsed on itself, swallowing trees, mountains, and everything else within the terrain. A caldera-forming eruption would generate a massive natural hazard in Yellowstone. Scientists articulate that the last Yellowstone eruption was 1,000 times greater than the notorious 1980 Mount St. Helens eruption that massacred 56 people and thousands of animals, and then burned hundreds of square kilometers of area in Washington and Oregon. The last explosion from Yellowstone's supervolcano fired up a lethal plume of searing ash, molten rock, and toxic gases thousands of meters into the air. 1/3 of the continent was likely plunged into utter gloom. Swift currents of hot, dry rock fragments and gases known as pyroclastic flows ran along the region at menacing speeds, burying and ravaging anything in their tracks. Magma spraying out of the ground scorched the once charming landscape for miles. Some remnants of the last eruption can still be seen in the Yellowstone caldera itself, 50 kilometers wide and 70 kilometers long. The dense volcanic debris that was left after the explosion still resides in an area that's referred to as the Lava Creek Tuff. All three eruption cycles included an explosive caldera-forming eruption that exhumed capacious volumes of magma from the volcano. Humongous pyroclastic density currents brought thick ignimbrite, and the area centered above the evacuated magma chamber collapsed to form a caldera. Today, the three nestled calderas are partially filled in by the world's most extensive rhyolite lava flows, which fan up to 30 kilometers from their source vents to thicknesses above 100 meters. More minor eruptions around the borders of the volcanic field have poured out basalt lava flows. Before eruptive activity in the Yellowstone Plateau, the surrounding mountains and valleys were present in their current structural arrangements, but with lower relief. The pyroclastic density currents produced during the explosive caldera-forming eruptions spread outward, filling up valleys and depositing ignimbrite tuffs in the surrounding mountains. Officials of the USGS, United States Geological Survey, say a cataclysmic eruption like the last one is a far-fetched scenario. Officials at Yellowstone Volcano Observatory, in fact, say the most likely activities to take place in the future are hydrothermal explosions, such as eruptions of steam and hot water, rather than molten rock or vicious lava flows. Although lava flows are a type of magmatic eruption, they are not as destructive as caldera-forming explosions. Instead of instant demolition, lava flows slowly leak out of the ground over days, months, or even years, and they're actually quite rare. The last one in Yellowstone occurred about 70,000 years ago, and even today, hikers can still see signs of those eruptions in the shape of striking rock layers along the trails in Yellowstone National Park. Some hints of younger lava flows can still be found near the cliffs that surround the Upper Geyser Basin close to Old Faithful, and today Yellowstone slumbers, with scientists checking its every hiccup or cough and struggling to predict its next move. Although the brewing force underneath the park has been restrained for thousands of years, Yellowstone's idleness does not mean it will never revive. The question is, when and with what force? We're getting into the period where it's supposed to become more unstable, says volcanologist Anderson, but I'm not holding my breath. If an eruption were to occur, it would be a disaster of global proportions. The supervolcano is capable of producing lava flows that would cover entire states, and it would also release a cloud of ash and dust that would block out the sun and cool the Earth's climate. For now, park officials are urging visitors to stay alert and be aware of the potential danger.